So in this video, we're going to explore models and images around the world, and the idea that if you're in Venezuela or Singapore, Texas, the United Kingdom, anywhere in the world, some models and images will transfer across geographic boundaries. So the first problem we're going to explore is inspired by Contando con los Recursos Matemática, in particular the Grade 4 book, which is the textbook that is used in Venezuela. So translated, the question says, it is correct to say that 2010, 4/5 of Colombians could have Netflix in their homes. Why? Okay, so like I said, this isn't inspired by, this is my own question. This isn't necessarily true, but there's some really useful maths in here. As I always say, the model or image or representation won't do the mathematics for you, but it will help pupils to structure their ideas and to get a sense of what's being asked. Okay, and so I would start any question about fractions and percentages by using a bar model. So we draw a bar and we show that this represents 100%, okay? Because that 80% is always relative to the 100% that there can be. We know that 80% is shown on the graph in 2010, okay? So 2010, 80% of Colombians had access to Netflix, again, made up. I don't know the actual figures, but what we can see is that this bar will represent the 100%, and we can explore that 80% in a little bit more detail. The question asked about fifths. The first thing we got to do is we've got to break this bar into fifths. Okay. So now we've got the context of the graph, and we've got our bar in fifths, and we're basically now trying to bring those two ideas together. So we know, our pupils will need to know, that one of those fifths is equal to 20%. Okay? So 1/5 and 20%. If they don't know that relationship, they're going to struggle with this question. And what we want to know is, do 4/5 equate to 80%? Okay? And we use that by counting. In 20s, we got 20%, 40%, 60%, 80%. And it does indeed show that 4/5 of Colombians had access to Netflix in the year 2010. So this example is taken from Texas Maths, again grade 4, and it says that 3 cattle weigh exactly 5,000 pounds. 2 are male and 1 is female. What are the breeds of the 3 cattle? Okay, and so when looking at this problem, we can again use the bar model to support us. So again, we start with the bar representing the total, the whole. And this time, instead of a percentage, it represents 5,000 pounds. And we need to find a combination of 2 male and 1 female that will give us the sum of 5,000 pounds and our 3 cattle. Okay, and so we can generalize this by saying, okay, one part is going to be female. Okay? We don't know the value of that part yet, but there are 3 possibilities. We also know that 2 parts are going to be male. Okay? Now in this image, it looks as if they're equal parts. That's not intentional. That's just the limitations of my skill with this medium. But what's important is that the pupils know that there's going to be 2 male, 2 of the same value, and 1 female of another value. And so it's going to be 2 male plus 1 female is equal to 5,000 pounds. And then from there, what they can do is they can try out the different possibilities. Again, the maths isn't done for them, but it is structured in such a way that they can look for 2 male, 1 female. In this example from Singapore, inspired by Primary Mathematics Workbook 3, which is probably written around grade 4, somewhere in that ballpark, you can see that Joseph bakes 54 cupcakes. Mary bakes 4 times as many. How many cupcakes does Mary bake? How many cupcakes do they bake altogether? Again, using the bar and the principles of representing these generalizations and the structures, we can see that we have Joseph's 54, and then we have Mary baking 4 times as many. Okay? And so by using these equal parts, we are showing the relationship between the different values that we're aware of. Okay, so we know that Joseph has 54 cupcakes. And so that means that Mary must have 54 times 4. You can see there's 54 plus 54 plus 54 plus 54. Okay? Okay. And so we can work out how many Mary has made simply by multiplying 54 by 4. The second part of the problem, how many cupcakes do they bake altogether? Yeah. So we can look at this in several ways, depending on what we want to draw attention to. Yeah. So we know that this is the total. We've got 1 part from Joseph, 4 parts from Mary. And we know that's 54 plus 54 times 4. And so if we're trying to draw attention to the distributive nature or the distributive property of multiplication over addition, we know that this is actually the same as saying 54 times 5. Yeah, and so by representing the problem in this way, we draw attention to the structure of the mathematics, and we make it a lot more accessible, and we can devote our limited working memory towards the actual calculations and solving the problem. Okay? And so, as you can see, it doesn't matter where in the world you are. These models are just as applicable. Okay? We could be in a school in Caracas, we could be a school in the middle of Singapore, or somewhere near Fort Worth in Texas, and we can get the same value from these images, which is why it's important that when we're learning about representations, we try to take in as much from an international perspective as possible, because there is lots to learn from people all over the world.